Anybody know this guy's name? Famous actor? John Travolta. Get it? Volts, electricity. And he's got his rubber shoe. Rubber likes to steal electrons on a carpet, and the carpet material, rub material, likes to give away electrons. So if I rub his feet or his foot, wow, you see those electrons build up and build up and build up. So he was balanced, now he's unbalanced because he has a negative charge, and they want to escape. They want to go somewhere. His finger, you'll notice, is awfully close to the doorknob. Doorknob's made of what? And that metal is a great conductor for electricity. So if I move his finger near the doorknob, what's going to happen? So you could try this by putting his hand different distances. I wonder if you can get a shock to go all the way that far if you build up enough of a charge. Today we get a chance to work with some static electricity. I've heard that you've already done some of these activities in your homeroom class, and so I want to take it up a notch. So I've got a couple new tricks that hopefully you have not seen before and I think you're going to enjoy. First one here is a cup with a little hole in the bottom. I just use a pencil and poke a hole in it. And trusty balloon here. It's made of rubber. Rubber likes to absorb electrons, steal electrons, I like to say. So I'm going to go ahead and just charge it in my hair. And I'm going to let the water come flowing down. And oh my goodness, I'm able to bend water. Once the water touches the balloon, though, it's going to lose its charge because electrons have been released. So you don't want to get it wet. If it's getting wet, it's too close. For this trick, we're going to try the soda can tug-of-war. I'm going to use 2 balloons, so you and a partner can do 1 each. And then I'm going to use the rug over here to charge these. And I like to hold them over my arm, where my arm here I can actually feel the static electricity. You and a partner or teammate can pull the can. Whoa, too far. Ah! So you and a teammate or opponent can play tug-of-war by pulling the can with static electricity. Pretty cool. Once it touches the can, however, the electrons jump from the rubber balloon into the can, and then it loses its charge. It doesn't really work anymore. So the goal is to get as close to the can without actually touching it to get it moved. Soda can tug-of-war. Okay, this station, there's obviously a plasma ball here. This is not static electricity, but it behaves in the way that static electricity does. There are electrons being pumped from the center of the globe outward, and they're looking for conductors, the easiest way for them to escape. And so by placing your hand in an area, you are able to see how the electrons gather together. This is very similar to how lightning works. Lightning wants to find the path of least resistance, the easiest way to get from one place to the other to release those electrons. So in this case, you just put your hand on it, you can watch it happen. Please don't touch each other. If it accidentally shocks, it won't cause any damage, but it's uncomfortable and it's just rude. So please be respectful of that. Another neat trick with this is you could hold up a light bulb, in this case an incandescent, nope, this is a fluorescent light bulb, CFL, compact fluorescent, and without even touching it, wow, the electrons can flow. Nikola Tesla was doing this over 100 years ago. People couldn't figure out how he was doing it. A lot of his technology is still not even understood today. And then over here, you have the old incandescent light bulb. This is the kind with the filament or the wire inside that heats up for electrons. And you can try that one and see if it works. I've noticed it does not work. I'm wondering if it's because the fluorescent bulb has a gas inside. The electrons excite the gas and light it up, whereas this one does not. This is actually a vacuum. The air has been pulled out, and there's a coil or a filament that's supposed to glow. Here we have the biggest and the best of all. This is called a Van de Graaff generator. The way it works, there's a rubber band inside here, rubber, like rubber balloons, like to attract electrons or steal electrons. So as they're getting sent, the rubber band is rubbing. It's building up a negative charge. A negative charge means they are repelling against each other. They're like charges they want to escape. So if you watch Barbie's hair, it takes a little while to charge up. But eventually, those electrons crowd together and they don't want to be there anymore. They want to balance out. In order to do that, they're going to jump wherever they can, either out through her hair or over to this guy. This is called a discharge wand. And the way it works is this wire is plugged into basically what's called a ground. That means it's a safe place for the electrons to go where they're not going to hurt anybody. And when the charge builds up enough, those electrons will either jump over to the discharge wand or, as I mentioned earlier, now, if I seem scared, it's because I am. This thing has zapped me several times. It will not put you in the hospital. It's not strong enough to actually cause damage, but it stings. And it's very shocking. It's very surprising. So please don't even get close to it, because just by being close, your skin is a conductor, which means those electrons will try to escape by passing through you. What you can do is stand safely over here, and this discharging wand is made of PVC. It's a type of plastic, I think, which is not a good conductor. That means those electrons are not going to go through there. And what you can do is you can lean it forward closer. You can actually watch the electrons create a spark, which is the same thing as lightning. It is lightning on a much smaller scale. After each jump, it's got to recharge, just like the balloon. If you touch somebody with the balloon, it loses its charge and it balances back out. You want to keep it rubbing to keep building up the charge, which is what the rubber band is doing all the time. Also, you'll notice her hair will start to pick up, and every time the electrons jump into the discharging wand, her hair will settle back down because, again, it's balanced, it's lost its charge. Woo, there it goes. Okay, I'm actually feeling this in my hand. It's tingling, it's not a good sign. So I'm gonna let it go ahead and let it jump back. Watch your hair. Oh yeah, they got me a little bit. Woo! So, Van de Graaff generator. Have a healthy sense of fear around it. It is wonderful and it is scary, so just be careful. You turn it off and you think it's done. But look at Barbie's hair. Her hair is still standing up, which means those electrons are still bunched together and they are pushing each other apart, repelling like charges repel, trying to get away. That means it's still got electricity in it, which means if I touch it or get near it, it's going to zap me. So I'm going to use, again, the discharging wand. Watch her hair. Boo! Go down. Now that's interesting. Her hair is still charged a little bit, but it is now safe to touch. Just kidding. This is another fluorescent light bulb. This is from the ceiling, and this has a gas inside. What happens when that gas gets excited by the electrons? Let's find out. Okay. Ouch. That was awesome, but it actually zapped me a little bit. I'm not sure that's a good idea for you guys to do. Woo! Again, it doesn't cause damage, but it's painful. Question: is static electricity a good source of energy for us to use in computers? Static steals, sticks, stays, and strikes. Ouch! Which means it's got power, but it is unpredictable, and it is sudden, so it doesn't last very long. Oh, okay, yeah, don't do that. That hurts. Ouch. Still a cool lightsaber. For this station, it's called Fun Fly Stick. It should be called Static Stick, because that's really what it is, but Fun Fly Stick got this on Amazon like 5 years ago. The way it works is you have this wand-looking thing here, and there's a little white button, and when you push it, you hear the buzzing. This works the same way that the Van de Graaff generator works. It's got something rubbing in there, which is stealing electrons from one place and storing them up. So it's got an unbalanced negative charge. And when you get one of these little pieces, the big ones used to work, but it's kind of getting kind of weak. And you put it on here and you turn it on. It also builds up a charge. Right now, that piece is full of electrons and it wants to get rid of them. And the Fun Fly stick is full of electrons. And so like charges repel. And so it seems to magically. And I want you to notice I'm not even pushing the button anymore because it's already built up a charge. I wonder if I touch this. Look at that. Ah! So when I touched it, I discharged it, which means that the electrons went into me, didn't shock me or anything. So if that happens, if it sticks to you, because it's going to, because it wants to get those electrons out, just put it back on there. And then again, push that little white button. And boom, it repels. Magic. Science.